Today we are going to look into detail on how Kserve can be used with LLMD and VLLM in complex deployment scenarios for inference on Kubernetes. We're going to look at how this integrates with the Kubernetes Gateway API and the Gateway Inference Extension, GIE, to bring high-performance inference to your Kubernetes cluster. LLMD is a Kubernetes native high-performance distributed LLM inference framework. It orchestrates VLLM in a variety of ways to bring state-of-the-art inferencing performance through several optimizations. LLMD has several well-lit paths for configuring these optimizations, and we will look at two in particular today: precise prefix cache-aware routing and prefill decode disaggregation. The usual route for trying out these configurations is through the Helm file supplied in the guides. We can get a picture of what these produce with the Helm file command so we can preview them. It consists of two deployments and a gateway configuration, the endpoint picker and one or more workers running VLLM. The Kubernetes gateway is implemented in this case by Istio, but others are possible such as Envoy, K-Gateway, etc. There are other support objects here like RBAC and config maps too. The important point is that the endpoint picker object implements the gateway inference extension. This is really the heart of LLMD. This endpoint picker is doing the intelligent routing of requests to the VLLM pods. The open source Kserve project gives a higher level abstraction of all of this, the LLM Inference Service CRD. Rather than configuring objects with Helm, Kserve has written an operator that will do all this work for you. You just have to give it the configuration, and it will go off and run everything for you. For convenience, there is a template LLM Inference Service config CRD for this configuration, so that it can be shared as a base ref across many instances. We add the bulk of the configuration into this template and reuse it when deploying a model for inference. There are actually a whole library of them installed as part of the project. Here is an example configuration we have created for the precise prefix cache-aware routing well-lit path deployment. The router section is for the endpoint picker configuration, while the template section is for the VLLM inference pod configuration. In Kserve, we have configured Envoy to implement the Kubernetes gateway, and here the EPP router will implement the gateway inference extension. Each of the VLLM pods will need access to the model. This can be a big download, and duplicating it in each pod is inefficient. It's better to download this in advance and save it to a persistent volume. We do this through a job and then refer to that PV in the configuration. The well-lit paths outlined in the LLMD docs are available here in Kserve too. For instance, prefill decode disaggregation that we saw in the well-lit paths is an advanced deployment method that can reduce inter-token latency in responses and hence improving interactivity. In this kind of deployment, we can see we have VLLM pods dedicated to prefill phase and to the decoding phase of inference. The communication between these pods can be over NVLink when GPUs are on the same node, or over high-speed networking like RoC-E across nodes, but both are abstracted by the NIXL library. The scheduler here has an important role in deciding whether to disaggregate a request or not, depending on the context. In our example, we've a 20 billion GPT OSS model for demo purposes, although generally the method gives the most advantage on bigger models. Here we've installed a new deployment alongside our others in a new namespace. You can see that we want two replicas of prefill pod on GPU MIG partitions because we're sharing this cluster with other users. As you can see, there are two prefill VLLM pods and one decode VLLM pod with its sidecar. We also have the scheduler pod hosting the endpoint picker orchestrating the requests. The service gives us the internal endpoint on port 8000. To test the deployment, we have the Open Web UI installed as a front end, and we can connect it up to our endpoint. Now when we start a new chat, we can see the performance and content that our deployment produces. Here I've entered a request previously, and now I'm going to follow on with another question. To track the performance, we have Prometheus and Grafana installed, and have linked up these pods through a service monitor. We can see the results when we look at the Kserve dashboards. These show the endpoint picker metrics and the VLLM metrics in great detail. Also, the NVIDIA DCGM metrics reflect the split workload on the GPUs between prefill and decode pods. We have added a guide around this to the upstream Kserve project that describes all the configuration. It focuses on GPT-OSS20B model, but it could be applied to any similar model. The guide covers the well-lit paths of prefix caching and prefill decode disaggregation in a multi-GPU setup. Thanks for watching.